Hi everyone, good day. Welcome to Agatech Institute of Electronics. Today we'll be checking this Samsung A750. It came like this. It came from another workshop, from another engineer, and I was told that it was water damage and he has given it a try. It did not work. So now my best guess is that water have entered probably under one or two of the metal shield. I don't have a thermal camera to check, so what will I do? Actually, I tested with DC power supply, and without powering the phone, it's taking 0.05 milliamp. I don't have a USB type that can display on the screen, but I also test with a USB meter to check the current that the phone is taking, and it's taking exactly the same thing as what it was taking when I plugged the charger, when I plugged the DC power supply. Exactly 0.05 amps. That's 50 milliamp. That's very poor. It should take nothing less than 1 amp, and with the DC power supply it should take nothing. Until you press the power button. So when I plug the DC power supply to it, I remove the battery and I plug the DC power supply, I discovered that it was taking 0.05 amp. So I tried to power it on, but it's not responding at all. So what will I do? I'll remove the metal shield because I don't have a thermal camera that I can use to test. So I'll remove the metal shield and look for sign of corrosion, sign of water damage to start with. We are interested in the panel. I'll remove the camera so that heat will not spoil it. Okay, I will start from this side. This side is more vulnerable because it's the one facing the outer part. The other side is still more covered, at least to some extent. And the way I see it is, let's just open it and see. Let's see how it goes. With the help of a PCB holder, I will hold the phone in place. It's not too suiting, but anyway, I will still try and hold it. And then I won't like to use a big hot air gun because almost all Samsung are gunboard. Almost all of them are gunboard. So I will use a smaller workstation. I'm setting my temperature to 400 degrees. I'm not telling you the temperature to use. I'm only telling you the temperature that I am using. I'm setting it to 400 degrees to remove the metal shield. I'll hit it and use my tweezers to try and lift it as soon as it melts, so that it will not affect the component under it. The thing has not melted, it's still hard. It's still hard. I'm concentrating on the same side so that once that part open, I can from there go to other parts. And it's gradually opening. Okay, and it's out. Okay, I think you won't see anything. Let me try and see if I can pick it with a microscope. Then I show you under microscope. Okay, there's no any sign of damage. There's no any sign of damage. I can't see. Okay, the engineer already put paste. Even if something had corroded before, it will not be very obvious because of the paste. Okay, I can see some sign of corrosion here. Here, let me touch it under the microscope. Somewhere around here, there's a sign of corrosion. You can see. We'll clean that up and see what happens. My microscope is not picking the name of this IC. It's probably the power IC because it's surrounded with a lot of power inductor and capacitors. I'm thinking this should be the power IC, and I'm guessing that the liquid actually enter on that it, because the phone is not even trying to power at all. It's not trying to power at all. So I will clean this part and see what happens. I'm using thinner. I don't have a isopropyl for cleaning. I use thinner and I'll use brush for cleaning. I'm using soft brush, so nothing will happen. This part is especially corroded. Let me put more concentration here, and I will test that capacitor for short. It's possible it's short. Sometimes I don't know why it happens that way anyway, but when there is a corrosion due to water damage, the capacitor is short. Almost all the time. And there's corrosion like that, a capacitor is short. I don't know if you know why it happened. You can write in the comment section below. I think it's fair now, but with what I'm seeing, the leg of this IC has corroded to these legs. Oh, you're not seeing, sorry. So those legs are corroded. The leg of this IC, especially this side, they have corroded. So I will try and put some paste to reflow it. And like I said, I will test that particular capacitor. This capacitor. No, sorry, this. I'll test this capacitor for corrosion, for short. My meter is set to continuity. So when I put it together, it should beep. If you can hear the sound. Now let's test the capacitor. Is it that it's touching this, or it is actually short? Let me use something more tiny for confirmation. I'm using the tip of a needle. Oh. Using the tip of a needle, and it's actually short. You can see. I guess right. Very, very correct. Before any other thing, I'll remove that. Oh, my soldering is not hot, so I'll use the workstation to pick it off. Take that off, and I guess that should be the only problem. Oh, you can see it has even broken. It was that bad. It was a very bad shot. Okay, we are good. I don't want to hit it too much. I don't want the phone to die. I don't want to be removing the flash memory and the CPU because it's gone board. So I will put it back and test. I want to believe that's the problem. Sorry. All right. I don't know how they do those things that you use two camera and you can switch between your microscope and the other camera. So I put the battery. Let me test the voltage that is on the battery in the first place. I didn't bother check. My black probe will be on the ground. Any open metal is ground. Let me try and zoom small so that you can see. Okay, this is the positive part of the battery. Yes, and we have 3.7. Let me show you. I don't know if you can see the meter. Oh, I want to put it in such a way that you will see. Okay, I will have to zoom out. I have to zoom out so that you can see. Yes, good. But I want you to see the point I am testing. All right, my meter is in volt. You can see is in volt. Now don't forget the black probe on ground and the positive probe on the battery positive terminal. And you can see it's having 3.774 volts. That's good enough. Now let's test with charger and see what we get. I'm using a power bank with USB meter so that you can see my charger is far away. If I use charger, you can see the USB meter. Okay, I'll have to remove this and plug it back to get the guy activated. Okay, now we're having 0 points. Okay, and it's working fine. We are good. We are good. It can be that crazy. I should not even have removed the metal shield. Now I will put back the metal shield. The capacitor that spoiled is outside the metal shield. Oh, you can see the demarcation for the metal shield. Let me use something tiny. My finger is too big to show that. You can see the demarcation and you can see the location for the capacitor. Now somebody might ask me, why is it working without that capacitor? Sometimes most of those capacitors are on the power line. If it's on the power line, there will be more than one capacitor there. You can see we have 36. We have 36 percentage. So I eventually put the metal shield back and I'm not returning the capacitor. I didn't return the capacitor. You can see the empty space for the capacitor, so I'm not returning it. And I eventually figure out the exact pin to power the phone, this power key with this key. So you will bridge the two together and that's the key to power it. It's not on yet. Yeah, and it's on. You can see Samsung Galaxy A7. Our phone is back to life, ready for use again. We've given the phone a second life. Thank you one more time. This is Agatech Institute of Electronics. Please subscribe and like the video if you actually like it. You can see the phone is fine, ready to work again. You can see it.